Division of fractions. We're going to divide 3 3/4 by 1 2/5. We could do an estimate here before we start. 3 3/4. 3/4 is almost 1, so we could call that 3 and another 1, 4, divided by 1 2/5. We could even say it's just 1, but to try to get a bit more accuracy, we could say this is a 1 and a bit. So 4 divided by 1 and a bit, wow, that's a bit hard, but we could say, well, 1 and a bit, almost 2. It's not really 2, but for dividing, it's important that we get a number that goes into the number we have to divide by. So 4 divided by 2 would be around 2. So we'll say 2, because it's 1 and a bit. Maybe we can say closer to 2. So let's leave it like that and see what we get when we finish the whole calculation. So these are mixed numbers, and we know that for any operation with mixed numbers, we will first have to change them into improper fraction. So start with the bottom, same thing, go around clockwise, multiply, 3 4s are 12, plus 3, 15. So the improper fraction looks like 15/4 or 15/4. Do exactly the same to the 1 2/5. Multiply and add, going clockwise. So 5 1s are 5, plus 2, 7. So we have 7/5. Now division is slightly harder, but we try to change it to a multiplication to make it easier. So what we are actually trying to do is check how many 7/5 go into 15/4. How do we do that? Well, the first thing we'll try and do here is just try to understand why we're going to do that flipping. So let's do here on the side. If we were talking about, let's say, an easier calculation, if we said 3 divided by a half. So what we are actually asking ourselves is how many halves go into 3? Think about that. We have 3 wholes, and we are checking how many halves there are here. So if you have everybody, what do we get? We end up with 6 halves in 3. How do we get a 6 now from this calculation? 3 divided by a half. Looking at the numbers, well, it's like we did 2 times 3. So that's why in this method we change the half into 2/1. We flip it over. We take the reciprocal. Reciprocal is swapping top and bottom, numerator and denominator. So we say the only way to get a 6 is if we change this to 2/1, and what else? We multiply to get the 6. So 3 times 2, 6/1. 1/1 is 1, 6/1 is 6. So that's why the flipping of the second fraction. So let's try to apply this here to the 15/4 divided by 7/5. So what did I say? And let's write it here. We keep the first fraction as it is. We change the divide into multiplication, into multiply, and the last thing we need to do is flip the second fraction over, if that is a way to remember. But it's important to see why we are actually doing that flipping. So 7/5, 5/7. It completely changes. The reciprocal is completely swapping top and bottom. So now we are back to a multiplication, and we know what to do. We multiply across. If we can, we try to first simplify to get smaller numbers. So 15 and 4, now we cannot simplify because one is a multiple of 2, the other one is not. 15 and 7, again we cannot simplify. 7 is a prime number that only divides by 7. So we try the 5. 5 and 4, again we cannot do it. 5 is a prime number, only divides by 5, and 4 is family of 2. And 5 and 7, same thing. 7 is a prime number only if we had 7, 14, or 7 and 7, 7 and 21, family of 7. So no way we can simplify top and top. Remember, only top and bottom, any top and any bottom, vertically or diagonally. So no option here. So what we need to do is basically just multiply across. So we have to do 15 times 5. We've done that before. 5 15s, 75. We could break it down saying 5 10s are 50, 5 5s are 25, 50 and 25, 75. Now we need to do the bottoms. 4 times 7 from our tables, then we need to know it, 28. Same as before, the top is bigger than the bottom, so that means 28 does go into 75. How many times? Well, we could do some calcs on the side. We know that 25 goes into 75 3 times, but here we have more than 25, so let's try doubling it. 28 2 28s will be what? 20 and 20, 40, 8 and 8, 16, 20 and 16, 56. Could we go one more? And we can write it down. We don't need to keep everything in our heads. So let's make room here for more thinking on the side. So if we said we have 56, 2 lots of 28, can we have another 28 in there? Well, maybe that will be too much. You can just check it on the side. Look at that. We have 84. That's over. So basically what we're going to say is 28 goes into 75 twice. 2 28s is 56. What's left? You can simply do the calc, counting up or doing the full subtraction on the side. We could even do 75, take away 56. So 15, using the subtraction method. 15 minus 6 will give us 9. And 6 minus 5 will give us 19. So we can say the remainder sits on the top, 19. The bottom is always the same, 28. If you don't like doing this calc here on the side, you can just do it in your head, or some people will just do it straight away like that. But one thing you could do is, let's try another one here. 56. We want to get to 75. Do some calcs like jumping to the easy friendly numbers. 56, go to the easy friendliest, the closest one. 60. How many units is that? 4. A jump of 4. From 60, then you can jump to 70, or you could jump straight away to 75. It's another 10. From 70 to 75 is another 5. So look at what you have on the top there. You have 14 and 5. 4 and 5 is 9. 10 and 9 is 19. So it doesn't matter which way you get there, and the more playing around with the numbers you do, the more familiar you will be with the numbers, and the easier your calculations will become. So comparing now our estimate, we said 2, well, roughly, because estimating with division, we always need to really round the numbers so one goes into the other. So we pretended that 1 and 2/5 was almost 2. So 2 into 4 would go twice. So we have an answer of 2 and 19/28. So we're happy with that.